Hello everyone, Assalamu alaikum. Myself Nafiul ID 1806176, and my lab partners are 166, 171, 181, 186, 191, and 1706011. Today, we are going to present the pre-winding process of three-phase induction motor. At first, let's see the presentation topics at a glance. Firstly, we will know about the three-phase induction motor. Secondly, we will explain the project procedure in detail. And finally, we will show the laboratory test result to confirm that our rewinding process was correct and motor works. Now let's know what an induction motor is. An induction motor is an AC electric motor in which the electric current in the rotor needed to produce torque, which is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connections to the rotor. An induction motor's rotor can be either on-type or squirrel case type. And here, the left side picture shows the on rotor and right side picture shows the squirrel case rotor.
This is the nameplate of the motor which we have used in this project. It is a 4-pole induction motor whose rated power is 1.1 horsepower. It operates at 380 to 440 voltage and its current rating is 2.05 ampere. It rotates at 1400 rotation per minute under the rated condition, and the insulation class of this motor is F. Let's see the procedure of this project. These are the steps that we have followed to complete this project. First, we have removed the stator wire and then rubbed those spots with insulators. Then we have made the coils with copper wire for rewinding. Those coils have been placed on the stator according to the model that was showed in the lab. Finally, we have tested the motor in the lab.
Without further delay, let's jump to the first step. The first step of rewinding is disassembling the motor. We have removed covers from the motor, rotor from the stator, and ventilator from the rotor axis. Let's see the video how we have disassembled. Later, we cut old winding from the stator, pull the windings and remove the paper of insulation out of the stator. And the next step is inserting insulation paper. First, measure the length of the slot, cut the paper accordingly, and twist it into rectangular sizes that fit perfectly to the slots.
For inserting copper wires in the stator slots, we have pre-wound the wire according to our desired number of turns for convenience. In this slide, we see the pre-wound coils that we have used. The wire we used in the stator winding was 100% copper with 0.02 mm diameter, and there were 92 turns per slot. For our motor, a single layer wiring diagram is used to create a 3-phase induction motor with 4 poles. Our stator shell has 24 slots in total, so the coil pitch of the stator winding is 6, the number of coils is 12. Each phase has 4 coils. The order of poles in the stator is north-south, north-south. For the rotor to rotate, it needs to pass the magnetic poles in this order, otherwise the motor will not start. If we cut the circular stator shell and lay it flat as a rectangle, we will see the 24 slots side by side like in the diagram. We have chosen the leftmost slot to be our arbitrary number 1, and the following slots are numbered accordingly. For our first phase A, as the coil pitch is 6, the first coil spans from slot 1 to 6, second coil from slot 7 to 12, third coil from 13 to 18, fourth coil from 19 to 24. The same way, our second phase B starts from slot 5, first coil spans from slot 5 to 10, second coil from slot 11 to 16, third coil from 17 to 22, fourth coil from 23 to 4. Third phase C starts from slot 9, and the first coil spans from slot 9 to 14, second coil from slot 15 to 20, third coil from 21 to 2, fourth coil from 3 to 8. As current flows in the clockwise direction through the coils, it induces magnetic north, and flowing in the counterclockwise direction induces south. So current flowing in the first coil of phase A from slot 1 to 6, it induces north pole. As the next coil needs to induce the south pole, current needs to flow from slot 12 to 7. The adjacent north pole will be induced by current flowing from 13 to 18 and succeeding south pole by current flowing from 24 to 19. So the ends of 4 coils in phase A are connected such that the coil N from slot 6 is connected to coil end of 12, slot 7 connected to slot 13, slot 18 connected to 24. Following the same principle, we have connected the coil ends of slot phase B such that the coil ends from slot 10 is connected to coil end of slot 16, slot 11 connected to slot 17, and slot 22 connected to 4. For phase C, the coil N from slot 14 is connected to slot 20, slot 15 connected to 21, slot 2 connected to 8. After connecting the coils, power is applied to each phase through the 2 coil ends. For phase A, power is applied to coil ends of slot 1 and 19 marked as A and A'. For phase B, the coil ends of slot 5 and 23 marked as B, B'. For phase C, coil ends of slot 9 and 3 marked as C, C'. For our reconstruction of the motor, the following video shows us reconstructing the motor according to the explained diagram.
We will discuss about the next and last part of our presentation, which is motor testing. Let's have a look how it can be done. To know about the performance and efficiency of induction motor, we do have 2 tests. These are no-load test and block load test. By no-load test, we can know about the information regarding no-load. They are core losses, friction losses, and also windage losses. We can do it by uncouple the motor from the load and run the motor at the rated power rate and also the rated frequency. And with the help of the wattmeter, we can measure the input power of the motor. Then we have block load test. We do block load test to find the leakage impedance. When we block the rotor by an instrument, then our speed of the rotor is going to be 0. When the speed of the rotor is 0, we get the slip to unity. And at that moment, if we increase the speed of stator till the rated value of the rated current, then we got the block load test parameters. We can find the rated current from the datasheet of SWT parameters, which is almost 10 to 4 ampere for our experiment for our BUETs. After that, we have armature or DC test. We do DC test to know about the characteristics of our components. We have to simply measure the resistance by multimeter, which gives us a value twice the one phase resistance. So we have to divide the resistance by 2.
After rewinding the motor, we went to our laboratory to test the motor. A quick demonstration of our testing procedure is shown. In our lab, at first we performed no load test. In this method, the motor was uncoupled from its load and the rated voltage at the rated frequency was applied to the stator to run the motor. Then we get the following values: voltage 400 volt, current 3.2 ampere and power 402 watt. Then we performed blocked rotor test. In this test, the shaft of the rotor was locked so that it could not move. The following readings were obtained from the blocked rotor test: voltage 150 volt, current 4 ampere and power 798 watt. And finally, we performed DC test to measure the stator resistance, and we got 11.2 ohm resistance for coil 1 and coil 2 and 11.35 ohm resistance for coil 3. That's all about our project. Thank you everyone. If you have any doubt or query, feel free to ask. I and all of my team members will try to clear your concept. Thank you.